almost at the end of our discussion on the first law of thermodynamics. So bago tayo pumunta sa second law of thermodynamics, let me just discuss a few relationships that might be useful for many different types of engineering applications. So unahin ko yung tinatawag nating Joule-Thomson effect. So yung coefficient na may kinalaman sa effect na yon, ang tawag doon ay Joule-Thomson coefficient. Okay, so ano tong Joule-Thomson coefficient na to? So, ang formula or the way we describe mathematically yung kanyang yung relationship na ito is that si coefficient ni Joule-Thomson, which we will symbolize it as mu jt, is equal to the derivative or change in temperature with respect to pressure when it happens at constant enthalpy. So kapag constant si enthalpy, ang tawag natin doon is isenthalpic. Okay? Now, ano ang application nitong Joule-Thomson coefficient na ito? So if you notice, kung positive lagi yung value ni Joule-Thomson coefficient, if you decrease the pressure, okay, if you decrease the pressure, ano mangyayari? It should be accompanied by a decrease in temperature as well at constant enthalpy, kasi you have to maintain the constancy noong coefficient. Ano bang ibig sabihin kapag bumababa yung pressure? So kapag bumababa yung pressure, ang tawag natin dyan is expansion. Alright? Now, kapag bumababa naman yung temperature, ang tawag naman natin doon is cooling, of course. So, at isenthalpic processes now, if you have your ideal gases, ang nangyayari is that if you expand your gases, nagkakaroon ng cooling effect. So, yun yung tinatawag na Joule-Thomson coefficient. And that's useful for cryogenic applications and also for throttling processes. Yung next na relationship na pag-aaralan natin is yung tinatawag nating thermal expansion coefficient, which is siguro mas familiar kayo sa relationship na ito. So thermal expansion coefficient. So ano yung mathematical form niya? Well, we will use the symbol alpha, and that will be equal to 1 over V times the change in volume with respect to temperature at constant pressure. Ang ibig sabihin daw niyan, kapag tumataas yung temperature at constant pressure, tumataas din si volume. And that's what we learn from physics, right? Yung tinatawag nating linear expansion. It's just that isa lang yung dimension na kino-consider natin doon. We don't consider area, we don't consider volume. But for gases, kapag tumataas yung temperature, tumataas din or nag-expand yung gases. Now, yung next will be yung tinatawag nating coefficient of thermal compressibility. How does it look like mathematically? We will use the symbol here na kappa. And that will be equivalent to negative 1 over volume times the change in volume with respect to pressure at constant temperature. So parang kabaliktaran lang siya ni thermal expansion coefficient, right? Si thermal expansion coefficient at constant pressure siya, ano yung change ni volume at with respect to change in temperature. Ito naman, change ni volume with respect to pressure at constant temperature. Now, given all these secondary relationships, balikan lang natin sandali yung equations natin for calculating change in internal energy and change in enthalpy. Okay, yung change in internal energy, kung matatandaan ninyo, it's this, no? So du is equal to cv dt plus the change in internal energy with respect to volume at constant t dv. So kung maalala ninyo, yung first term ng equation na to, that will be for perfect gases. So first term, okay, so let me write it here. First term, now let me just put the annotation in the actual equation. So kung gagamitin nyo tong first term lang, that's for perfect gases. Pero kapag gagamitin mo yung buo, yan yung general equation na for any gases. Okay? Now, in our discussion during determination of this equation, change in internal energy, na-discuss natin na yung second term is actually what we call pi. And pi, it's called internal pressure. Okay? Anong ibig sabihin yan? So kung mapapansin nyo yung expression, change in internal energy with respect to volume at constant temperature. So ibig sabihin, yung gas, if it's not a perfect gas, so ibig sabihin any gas, yung internal energy, may dependence na siya dun sa temperature, of course. If you increase the temperature, you increase the internal energy. At the same time, meron ding dependence sa volume. Okay? Kapag nag-change yung volume, let's say, nagkakaroon ng compression, malamang nagkakaroon na ng mas malaking interaction yung mga gas molecules. And because of that interaction, it will contribute to the internal energy. Okay? So, yan nga yung tinatawag nating internal pressure. Okay, however, for our equation for the change in enthalpy, which I will write now, di ba? Kung matatandaan ninyo, dH is equal to Cp dt plus the change in enthalpy with respect to pressure at constant temperature dP. And again, ganoon din, no? Yung first term will characterize your perfect gases, but for the whole thing, it will be for any gas. Okay? So, ang sinasabi niyan is that the enthalpy is dependent, okay, on temperature. Tama naman. Kasi si enthalpy dependent naman siya sa internal energy. So, it's the same relationship. And also, it depends on the pressure as well, right? So, nag-increase daw or nag-change yung enthalpy kapag nagbabago si pressure. However, itong term na to, we haven't really identified kung ano man yung kanyang identity. So, let's try to do that. Now, before we get to that, balikan lang natin ng konti yung mga math na inaral nyo sa calculus. So, if you have a function z, okay, z as a function of two variables x and y. So z is your dependent variable and x and y your independent variables. Okay, so what will I do is, if I take the change in z with respect to x at constant y, and I hope you saw what I did here. So z x y, okay, and then I multiply it with the change in y with respect to z at constant x. So, ano nangyari dito? What I actually did here is yung z napunta sa parang denominator, right? Yung y na constant napunta dun sa parang numerator. Of course, we don't call it numerator and denominator. So, it's like I'm moving all the variables here. So, it's like a cycle, no? Z napunta sa baba, y napunta sa taas, yung x napunta dun sa constant. So, ang kinalabasan is ito. And I will do it one more time. So, what will I do next is yung x, mapupunta na naman siya ngayon, this time sa taas. So, partial of x with respect to y at constant z this time. So, ganun din yung ginawa ko. Cyclic siya. Okay, so yung x napunta dito, yung y napunta doon, yung z napunta kay constant. So, if I multiply all these three, mag-i-equal daw yan mathematically sa negative unity. Okay? And we call this relation in math as Euler's chain rule. Okay? Or Euler's chain relation. Okay, ano ngayon? So what if we do it also with this term in your equation? Para malaman na natin ano ba talaga yung term na yan. So let's do that. So I will write here partial derivative of h with respect to p at constant t. Okay? So ang mangyayari, so let me just annotate this a little bit. Let's use red. So yung t mapupunta sa dependent variable, yung dependent variable mapupunta sa independent variable, and yung independent variable mapupunta sa constant. Okay? So, i-multiply natin yon dun sa original. So, times. So, ano bang mangyayari? Magiging partial derivative of t with respect to h at constant p. Now, let's do it one more time. So, yung constant mapupunta sa dependent variable, yung dependent variable mapupunta sa independent variable, and yung independent variable mapupunta sa constant. Cycle siya. Ano magiging resulta? We will multiply that there. So the result will be partial derivative of p with respect to t at constant h. And again, according to Euler's chain relation, mag-i-equal daw yan sa negative 1. Okay? Now, yung term na to, ito yung gusto nating malaman, right? How about the second factor? What is that exactly? So kung papansin niyo, medyo hindi natin kabisado ano ba yung term na yan. Pero if you will look closely, balikan natin yung mga secondary relationships natin kanina. Sorry, for this second factor rather, if you will look closely, it's actually the reciprocal of your heat capacity. Tama ba? Kasi ang heat capacity, remember, it's partial of h. Okay, with respect to t at constant p. Right? So, reciprocal siya ni heat capacity. Constant pressure heat capacity. How about this? So, kung titignan nyo mabuti, parang di natin alam. But if you will go back to our secondary relationships, and one of them being si Joule-Thomson coefficient, which is this. Diba? TPH. Pero ito, PTH. Ibig sabihin, this factor, this one, okay, is actually the reciprocal this time of the Joule-Thomson coefficient. So, let's go ahead and substitute everything that we have identified. So, of course, yung pinakaunang factor, yung partial of h with respect to p at constant t, siya yung hinahanap natin, so hindi natin alam. Okay, yung second factor is 1 over Cp. And yung third factor is 1 over the Joule-Thomson coefficient. So, equal daw yan kay negative 1. So, if we will solve for the partial of h with respect to p at constant p, which is yan yung hinahanap natin, just simplifying this equation, this will be equal to negative Cp times the Joule-Thomson coefficient. Okay? So, yung kaninang equation natin, which is for the enthalpy, right? So, isulat ko na lang again. dH is Cp dt, okay, plus partial of h with respect to p at constant TdP. And again, we are looking for the identity of this term. So we can now substitute. So therefore, dH is equal to Cp dt plus yung nakuha natin. So this is actually negative. So it should be minus. Okay, this one. Minus Cp Joule-Thomson coefficient dP. So now, ang nangyayari is kompleto na yung ating equation for the change in enthalpy for any gas, whether perfect or not.